Hey guys, this is the second video of my series, and this one will be covering OpenVDB and how to convert Maya fluids into OpenVDB, which you can then import into Redshift volume containers and render. And I'm not going to actually cover the process of making a Maya fluid. There's tons of tutorials on the web that you can check out to actually learn how to make them. And I'm just going to use one of the stock ones. You can find it actually if you go under Windows and you check out the where's it at? Workspace, under General Editors, the content browser. This is new in Maya 2016.5, but you can find this in all the older versions. It's just called the viewer. And so underneath here, under the fluid examples and explosions, I'm just going to use the Nuke. So you just click it, drag it out. And so I actually cached this out already, so that way it loads up quickly. And basically we're going to turn this into an OpenVDB, which you can then import into just about any other render engine or app. OpenVDB is the standard, kind of like Alembic cache is for geometry. This is the standard for moving volumetric stuff around, so between Maya, Houdini, etc., etc. And you can do this also with fume effects. You just have to make sure when you save the cache, you just choose VDB instead of whatever the fume effects cache uses as standard when you're saving it out. And so we got this cache going now, and it's just a simple explosion, nothing crazy. And the visual that you get here, don't rely on this, because we're going to be basically remapping all the information once we bring it into Redshift. Redshift's volume container is still in early development, so it doesn't have a ton of features. It doesn't have opacity and texture inputs, for example, which add a lot of little details that we just can't do yet. But for now, it's still pretty good. And so we got this cache going. Now you're wondering, okay, how can I render this in Redshift? If you actually just try to render this in Redshift right now, for example, we fire up the IPR, and nothing will actually happen. Oh, great. Don't freeze on me, Maya. Okay, no, there we go. It was using software for some reason. So let's actually try out Redshift. So if you hit an IPR, you get nothing. I mean, it just doesn't natively support Maya fluids yet. This feature will be coming in the future according to the devs, but for now, this is the only way you can actually render a Maya fluid in Redshift. So what you need to do, you need to actually download OpenVDB. I'll be linking to it in the description for you to actually go and download this. I won't explain the whole installation process because it depends on your system. The website gives you all the information you need. And so once you have it installed, make sure you have it loaded in your plugins section. So in your plugin manager, just make sure you have, Bisha's OpenVDB. And he's the dev that takes care of this and updates it. And so right now it supports up to 2017, so it works with everything that's the latest and greatest. And so once you have this loaded up, let's open up the node editor. And with the node editor selected, so let's move this to the side. Inside of here, make sure you go to the logo thing, and when you click on it for OpenVDB, there'll be tons of options. You can do a lot of great stuff with this plugin, everything from writing these out. You could do Bifrost, arrow sims, and you can write them out also. And you could add noise, just a ton of stuff. And so for now, all we're going to do is just a basic introduction on how to turn this into something Redshift can render into OpenVDB. And so all you got to do is you look for the VDB from Maya fluid. And so you click on this, it'll build one little node, and in here on the side you'll get these options of what channels you want to add. So for our example, all we're going to need is just density, some fuel, and velocity. And once you have these things checked off, you'll have the option of what name it's actually sampling this from. So right now it's just giving us the generic fluid shape, which is the name of when you actually make your own. But since this is something I pulled in from the content browser, we're going to use the name it has. And so right now it has the name Nuke Fluid. And so if we go to the shape node, we copy that, go back here, and we paste that in here. And so just hit enter. And now that it's going to be pulling all the density, fuel, and velocity information from the Maya fluid simulation that we got. And so now that we've got that, next node we need to make sure it's working is you make a visualize. So just type in visualize, hitting tab to open these windows up. I already know the names of these, so I don't have to go through all the list, but basically the BEVDB visualize. So you make this node. What this node allows you to do is to actually see what's going on in the viewport as it converts it into a VDB. So we're going to chain this up into there. We're going to click other. At the bottom we have VDB input. And so what basically is going on is oh, I just got an error. For some reason the name is not correct. Let me oh, here we go. Okay, this is the name we needed actually. And so let's hit enter. Okay, so now we got this grid, the OpenVDB grid, and let's just hide our actual simulation now so it doesn't get in the way. And inside the visualize node, we could click on density, fuel, velocity. We want to just make sure it's actually loading something up. So we got this shape, the general shape, and you could check out the surface by clicking surface, uncheck the leaf nodes, and this lets you basically visualize, okay, the Maya sim is actually being converted into OpenVDB and it's doing its thing. And you just want to do this just to make sure, okay, it's actually working. And so now that we know this is working, we need to write this file out, this OpenVDB file out. So what you want to do is type in write, and you get the BEVDB write node. And with this node selected, you want to pipe out from the Maya fluid conversion VDB output into the VDB input. And then instead of having this wired through, we're going to actually pipe that back into here. And this is actually an important step. The cache won't write out unless you actually have the write connected to a visualize. If there's nothing to visualize, the cache just won't write. And you have to make sure it's actually in viewport. So you have to be able to see what you're writing out. And so now that we've got this node set up, and we got our name, our density, fuel, and velocity. We need the velocity for motion blur, otherwise you can uncheck that. And you just have your write node now. And so in here, in the VDB file path, you need to give it a destination. And so we're going to name this Nuke test, which is the Nuke explosion. And as you let's start that over. As you put the if you want to write out an animation, you actually have to put a point and then padding, frame padding, using the number key. And so this is 4 frame padding, and then .vdb. And so this is basically, you have to add this 4 frame padding, and what this is telling OpenVDB to do is basically to write out all your animation frames, and so to cache. And so you hit this, make sure it's saved. So what you're going to have now is the destination on your hard drive, wherever it's going, and then the name that you chose to give it. So we're giving it Nuke test dot, and then 4 number signs, and then this is the frame padding. So basically it'll be 1, 2, 3, etc., and you're giving it 4 because 4 is just a good number in case you have that many, 1,000 frames or whatever. And now that it's ready to go, all you have to do is just go back to the beginning of your whole scene, and it should just play out the entire write cache. So let's hide that for now. And so if we go back to the beginning, press play, you see we got the VDB being written to cache now. So let that load for a second. And once this is done being written, we can then actually import it in either into a new scene, another scene, whatever you want, or into this very same scene and use it with a Redshift volume container. And then you could light it, shade it, do whatever you need to do with the VDB cache. And so let's let this write out for a minute. And by the way, there's also an actual script that does the chaining to export automatically, but I think it's a good idea to learn what the nodes are actually doing and how to put them together yourself. I'll be linking to the script also in the description. I'm not sure if it works with the latest Maya 2017. I know it works with 2016.5, but I haven't checked if the developer has updated. So that's why I didn't bother to actually use that shortcut for this video. I'm actually showing you how to do it manually, just because if the script doesn't work for whatever reason, you'll at least know how to do this step by step. And so it's almost done caching. And once this finishes, I'll be importing it into a Redshift volume container as a sequence. So that way we could scroll through and see this as an animation. I'll be pausing the video right now just so this goes by, and I'll be continuing where we left off. Hey guys, so now that we've cached out our VDB, as you can see, it's all in location, it's cached out. We can now actually import it into a new scene and render it out with Redshift. So let's get started with just a basic plane, just to have the floor, something to cast a shadow on. And in Redshift, let's make a dome light. We don't need an HDR or anything. We're just gonna, I don't know, just for a little bit of GI, make it nice and dark. And now that we've got that going, we're gonna bring in that VDB sequence. And so you go up to the Redshift tab, and underneath volume, there's two options. You can just bring in the VDB without a material, or you can bring it in together and already have a material built connected to it. And I personally just do this so that way you can start working on it right out of the gate. And so we hit that, you'll get this little cube in the center of your scene. Let's click this, and it's under your Redshift volume. So once you select that, you'll have an option to lay to point this to the position of your VDB file. And so I'm going to go to the first, and we have an animation, so we're going to check off use file sequence. And what this will do is it'll just load every frame as you go of the cache. And we're going to change this to points with a bounding box. And so what this does is it lets you visualize it. So if we actually move forward in the animation, you get this. So if you only have bounding box, you can't really see the general shape. And points is just the points by itself. I prefer to have the box and the points. So now we know, okay, it's loading something up. It's gathering the information. And the next step, if you want motion blur on your VDB, is right underneath, you'll have the motion blur section. You have to right click and add your velocity options that we exported earlier. So we're going to go X, Y, Z. And if you want to increase the motion blur strength, you can basically lower this, or I personally leave it on 1. I think 1's fine, but if you want to increase it or decrease it, you have the option here. And this section tells you all the channels that were exported when you created the VDB. So let's say you're loading a VDB cache from Houdini or Fume Effects or Softmage, whatever app you're using. You will be able to actually see the options. They'll be listed off right here. In the past, you didn't actually have this, so you kind of had to know what the naming convention was. Nowadays, it's a lot easier. So, okay, cool. Now we've got the VDB loaded in. If we skip around, you can see how it's doing its thing and loading and whatnot. So let's check out the material now. So I'm going to go to the material attributes. And so this is what a Redshift volume material looks like. And basically you have the scattering or density channel section and the emission. So this is like the light that's being emitted. If you're building like a cloud or something, not an explosion basically, but smoke, a cloud, fog, you don't need to actually add anything to the emission channel. And so I'll actually show you the difference right now. And for now, we're going to just load up density. And so when you right click on this, you could pick what you have for channels. So we're going to go with density for the scattering. And let's actually fire off an IPR right now. So let's see what we get. And so this is what we got right now. Nothing exciting really. And the dome light's a little bright. Let's darken it so we can see the emission later. So actually this was supposed to be at 1 and exposure is supposed to be down. And let's get rid of the background also so it's not just a white background. And so I believe we have GI on. No, we don't have GI. Okay, so let's turn on brute force, and let's bring in a light. So we'll just make a physical light. And right now, basically, if you want it to contribute to the shading of the actual volume itself, underneath all the Redshift lights, so the physical light, the dome light, there's a section for volume contribution. So if you increase this, let's just make this a little bigger so you can see what's going on. If you increase this, now it's actually shading your volume. If you have this at 0, it's not, any of the lights are not actually affecting the volume. And this is true also for environment fog. And so let's crank that up. Right now it's a little strong. Let's go with I don't know, 25. Let's change the color to something cool. Blue. It's a little bright. Let's actually desaturate that a little. So now we got this nice cool blue light going on. And let's make this invisible. So in the visible section, let's just turn that off. And so right now, we just have basically what looks like a fog. And it's not an explosion, there's no emission right now. So if we go back to the material section of the volume, since there's no emission, there's no light being emitted. So it's not an explosion basically. Right now it's just smoke, as you can see. And to change this, we need to now bring in the fuel. And so right now the ramp is black and white, so the fuel is just blowing out everything. It's super white and strong, but you can see it's affecting the GI on the floor. And so we're going to click on the ramp and remap this to something more explosive looking. And so we go with the yellow, make another one. Let's go with more of an orange. We're going to go with like a darker reddish brown. And so now we've got this. You can obviously, tweak it to your desires. So more this way, or let's, crunch it this way a little. Bring in more of the black this way. And so you have a lot of options in how you want to approach this. And every VDB has its own what will look good, what ramp, how you set it up. So always play around with this to your own liking. And so now we've got some fire color going on. And to change up the rest, to get it looking a little closer to how we had it, we need to now work on the densities. And by the way, the scatter ramp, this allows you to change the color of the actual smoke. So while this changes the color of the fire, so let's just delete that for now so you can get an idea. So what this will do is this will actually change the color of the smoke. So if we move this more this way, we're actually clamping on the smoke and the scattering of the smoke. And this goes the opposite way. So now we're getting a lot more. So let's do something like this. Black basically cuts into it, white exposes it. And the what this selected color section is basically just lets you, while you select one of these, it just lets you tweak it. I personally just like clicking that and doing it here. And you can make this as big as you want, so it's easier to create a nice gradient. And so now we have this section of the scatter coefficient. What this does is basically it increases how much the light is going to scatter in there. And so if you increase this, I don't know, to that, you're getting way more influence from the physical light we had here. And this also applies to the emission. So if we turn this back on, it's going to scatter way more of these colors inside of the smoke. So I'm going to just keep that at 1. So you can actually go lower, and it darkens it. It basically lets less light scatter. So we're going to keep it at 1. Tint. This tints the color of the smoke. So if you want, like, I don't know, red, for example. Now we're going to get red smoke. So you can change this to whatever you want. I'm going to just keep it at white. Or we could go with something a little darker. Black, whatever, right? But let's just keep it at white for now. And your interpolation, so how you want that to happen. Linear, smooth for your gradient. I just leave it at stock for now. And the absorption, so this is how much the smoke itself absorbs the light. So this scatters light, this absorbs. So if I increase this, it's going to just get thicker, darker. The smoke basically thickens. So let's do something like, I don't know, let's just try 5, see what happens. And let's increase the dome light a little bit. Just, I don't know, get a little more light on. Oh, well, too much. Not a 4. -4, 3. Yeah, -3. And this plane, let's turn this plane into, actually let's make another plane so we can light the back over here with something. So we'll open up the new Maya 2017 light editor. And so let's we got the dome light, the physical light. Let's build another physical light. Redshift doesn't have icons yet. They're working on these. So right now you gotta scroll over it to see which one's which. So we'll build another physical light popped up down there, and we'll just use the camera preview section. So there's a little camera. Click on this, and what it does is it opens up this convenient little window where you're seeing through the light first person. And so let's move around to up here. Let's point downwards. Maybe a little higher. Let's move this way. Okay, this is cool. And so from here, you could the light editor is really useful feature, and you could turn off and on lights and whatnot, and you can select them quickly. And so now that we've got this light going, let's tone down actually the dome light a little bit more. So we get some little rim light going. -5. And for the tint, let's do a nice cool dark cool color, purple or something, a dark color. And let's change the this physical light intensity. Let's do something like 5. Just okay, let's try 10. Okay, 10. Now let's change this second physical light. And we could actually close this now since we like the position. And we'll change this. It's way too bright right now, so let's try 15. And the color for this, we'll go with this something a little warmer. Okay, that's cool. And let's just remove the visibility on it. And we'll turn this into a, I don't know, let's just try, instead of a rectangle, we'll go with a disc. Let's actually do that for the other light also. So now we got disks. Okay. So now we've got a decent little light setup going. Let's crop the IPR section so we're not constantly loading everything else. So let's close the light editor. And now that we've got that, a decent light setup, let's go back to our shader, our volume shader. And let's turn on the fuel emission now. And so boom, now we've got this it's really strong. It's overpowering pretty much everything. And so at this point, let's actually darken the scaling on this so that the scale basically is the same thing as the scattering and the absorption scaling. You could either make the emission stronger or weaker. So if we go up more, as you can see, it's making it a lot more intense. Go down more, it's more subtle. So let's try 0.5, 0.75, keep it at 1, 0.2, 0.5. Yeah, let's just keep it at 1. Maybe we could just adjust the ramp itself. Maybe crush the blacks in more. Bring this maybe to this side. Pull this out. Go this way. Let's actually just do a test render. So right now it's super grainy, but that's just because the lights samples need to get increased for the volume samples. So under the volume samples, let's crank this up to 128. For the next physical light, 128. Oh, and I forgot to turn this on, so let's turn that on also, which actually should change the lighting completely. This is something I sometimes forget to do, so it's a good idea to turn that on actually. And that just, if you turn it off, it's subtle, but it basically adds the light to it. And where were we? 128, 128. The dome light right now I have it off. I don't want it to contribute. I could turn it on and have it contribute, but yeah, you know, for our purposes, I think it's better off. So let's get the samples up and let's actually do a little test render. And we'll increase the volume samples 256. See how we do. Max samples 256. Let's try this out. Okay. So right now we're getting motion blur. Motion blur, actually, you don't have to turn it on in the options for VDBs. To turn on motion blur or turn it off, you could actually just do it from the VDB file itself, the volume container. So if you select it, you have the velocity scale. So if we increase this, just so you guys can see the difference, hit that again. Yeah, so now we're getting like crazy motion blur. A little too much. And if you turn it off, we'll get 0. So this is closer to the original shape, but motion blur's cool. So let's keep some motion blur going. Maybe too much, 0.5. Yeah, so that's fine. And so since volumes take quite a lot more samples to clean up, it's just the way it is. So let's increase the GI to 256. And for memory, let's add a little extra, 2 gigs extra of GPU memory. And let's see how it looks. Still needs quite a bit more samples. Let's try 512. 512. let's increase the volume, I don't know, 512. Let's override the lights actually also. Let's go with 256. So this is going to slow it down quite a bit. But slowly getting a little cleaner result. And yeah, so let's, now that we've got that going, you can skim through it, check out what it looks like now. So let's fire off an IPR. So now the fuel has been spent, and so that's why you're getting less fire basically as the simulation continues. Oh, and actually we're beyond the cache count. The cache ended, I believe, at 90 something. So let's change the frame length. 98. No, 80. Okay, it ended at 89. So let's trim our scene actually. Okay, so let's check out the IPR. So now we've got basically only smoke left. All the fuel already burned out from our simulation. So if we go back to the beginning, check out what we've got. We've got the initial explosion, the fuel burning, and then it's growing a little bit. So we got that explosion, boom, going up. And I mean, look at the speed of this. I mean, this is amazing. On a CPU, volumetric stuff is just super slow. And so now we're getting, you know, almost basically real-time feedback on a volumetric render. That's just incredible. Redshift is just mind-blowing how fast this is. And so, cool. Now we can see kind of what's going on. And so now all that's really left is to just render out the animation.